Okay, the final page. So let's see what we got here. Solve each of the following on the interval from 0 to 2 pi. Okay, so let's see here. We're going to do, so this is a quadratic. I have a cosine squared, and I'm going to do the u substitution here. Let u equal cosine of x. So that's going to give us 2u squared minus 5u plus 3 equals 0. So a is not 1 here, which is kind of annoying. So let's do the x method here. And if I remember this correctly, so we're going to divide both sides by a when we're done. So dividing both sides by 2. And so this one is a times b. No, a times c. Hold on, let's see if I can't remember how to do this. So, c is just times itself, so c should be by itself. I think b's by it. I think it's a times c. So a times c is up here, so that's going to be a 6. So 2 times 3 is 6. And then b is negative 5. So I need to figure out what two numbers multiply. Is that going to work? 6 and negative 5. Yeah, a times b, a times c, b. So which numbers multiply to be 6, but add to be negative 5? So that should give us negative 3 and negative 2. And we divide both of these here, so this is just going to be a negative 1. So we should end up with, this will be 2u minus 3. Right, yeah, 2u minus 3 times u minus 1. Think that'll work. Just to make sure, 2u times u is 2u squared. Awesome. 2u times a negative 1 is negative 2. Negative 3 times u is a negative 3, so that gives us negative 5u. Great. Okay, that works out. So that means that I'm going to run out of room here, so I'm going to get me a scratch sheet of paper. So that means either 2u minus 3 equals 0, or u minus 1 equals 0. So u equals, add 3 to both sides, divide by 2, so u equals 3/2, or u equals 1. And u is cosine, so cosine of x equals 3/2, and cosine of x equals 1. So cosine of x equals 1, well, cosine is 1 at 0. So that will just be 0. So x equals 0. And then there's no reflection there, no vertical reflection to worry about. And then here, you'll get the inverse cosine of 3/2. That doesn't sound like... Are we allowed to use a calculator? If we're not allowed to use a calculator, that'd be annoying, but I would assume we would, because 3/2. Let me check my work to make sure this isn't supposed to say 1/2. And I don't think it is. Okay, I don't think it is. So this will be x equals the inverse cosine of 3/2. And then we'll also, so that's going to be a quadrant 1 solution. We're also going to need its vertical reflection, so we're going to need the quadrant 4 solution as well. So we're also going to need the reflection 2 pi minus inverse cosine of 3/2. So we'll plug this into the calculator. Yes, yes, battery low, but you're going to be a hero and you're going to make it through this last page. So inverse cosine of 3/2 is domain error. Why is it a domain error? 2 cosine minus 3. So positive 3/2. Yeah, a domain error. Why is it a domain error? Well, that is because this is bigger than 1. Inverse cosine can only have a fraction here that is in between -1 and 1, so this is undefined. So 0 is our only solution. I'm going to be honest with you, I'm not terribly confident about this. I haven't done this question before. So what I'm going to do is I'm going to see if that is true. So let's see here. I'm assuming we get to use a calculator for, I guess if it's 3/2, that makes sense. 3/2, subtract 3. Yeah, all that works out. Positive 3/2 and a positive 1. Yeah, that's fine. So yeah, this is undefined. Inverse cosine of 3/2 is undefined, so it is not a solution. No solution there, so that is our only solution. Here I have cosine squared plus 4 sine x plus 4 equals 0. Okay, so this one is going to be annoying because these are different functions. These are different functions. So what I'm going to do is I'm going to change that function right there. I'm going to change this to be 1 minus sine squared x. Cosine squared x is the same as 1 minus sine squared x. Plus 4 sine x plus 4 equals 0. Then I can collect like terms. I have a negative sign here, so collecting like terms, I get negative sine squared x plus 4 sine x. 1 plus 4 is plus 5 equals 0. And then, because I don't like having a negative for my a, I'm going to multiply both sides by -1. And if I do that, I get sine squared x minus 4 sine x minus 5 equals 0. Okay. So here we can try and factor it out. Maybe what two numbers multiply to be -5, but add to be -4. That should be, so I'm going to go back to my own room here. So let me rewrite this. Sine squared x minus 4 sine x minus 5 equals 0. So I should be able to factor this into negative, so multiply to be -5, but add to be 4, so -5 and 1. So this will be sine x minus 5 times sine x plus 1. And if you did u substitution here, you'd get u minus 5 and u plus 1. So now we know that sine x is equal to positive 5, or sine x is equal to positive 1. Take inverse sine of both sides. X equals sine inverse, sine inverse of 5, and x equals sine inverse of 1. Sine is 1 at the top of the graph, which is pi over 2, so we get pi over 2. And then inverse sine of 5. This is outside the domain of inverse sine, so it is undefined. So we just have the one solution, x equals pi over 2. Okay, 4 cosine squared of x minus 3. So again, this is another, oh, sorry, get a little comfortable. Another quadratic, but I have the squared term. I don't have a linear term, which makes this kind of easier. I can just move everything over. So this will be cosine squared x equals positive 3, divide both sides by 4. So cosine squared x equals 3/4 square root both sides, and we get cosine x equals, we have two cases, the positive and negative, plus or minus. So we'll have square root of 3 over 2, and we'll have cosine x equals negative square root of 3 over 2. We take inverse cosine of both sides, so it's everywhere that cosine is root 3 over 2. So this is all of the over 6's. So this is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, because we only want the solutions on the first circle of the unit circle, or first rotation of the unit circle. So there's our 4 solutions. Okay, here I have tangent x sine x plus tangent x equals 0. Again, we have two different functions here. I would want to try and make them all sine, but if I did that, if I make this sine, or make this sine over cosine, that makes it sine squared over cosine, and I feel like that starts to get a little rougher. So instead what I'm going to do, these both have a tangent on them, so I'm going to factor out a tangent. So I'm going to get tangent of x times 2 sine of x plus 1 equals 0. Now, even though I have two trig functions, they're being multiplied together and they equal 0, so I can break them apart with my two cases. Tangent of x equals 0, or 2 sine x plus 1 equals 0. So tangent of x equals 0 at 0, and plus pi k, so at every pi afterwards. So from 0 to 2 pi, it'll be 0 at 0 and pi over 2. Not pi over 2, 0 and pi. 0 and pi is when tangent is 0. And then this is be subtract to get a negative 1, divide by 2, so sine of x equals negative 1 half. And sine is 1/2 at the over 6's. At the over 6's. So we just want the negative ones, so that's in quadrant, sine is negative in quadrants 3 and quadrants 4, so we just want the 7 pi over 6 and the 11 pi over 6. So there's our 4 solutions. Okay, verify the following is each of these identities. Shouldn't need a calculator for any of these. Okay, when it says verify, usually you just work, you can't move anything over, like you don't add or subtract anything to both sides, you just simplify things. So for example here, this is already sine and cosine, so I'm going to leave it like that. We can make this one, what's cosecant times sine, so this will be, cosecant is just 1 over sine. So 1 over sine theta times sine theta plus cosine squared over sine squared is cotangent squared. Cotangent squared theta. I'm not sure if I'm going to want to do that. Maybe it's better to leave it sine and cosine. Maybe it's better to leave it tangent. We'll see how that works out. So 1 over sine times sine, so that cancels out that, leaving just 1. So this is cotangent. This is cotangent squared theta plus 1 equals cosecant squared, and that is done. That is a Pythagorean identity, so that is the same. So those are equal to each other. Okay, this one's require lots of algebra. Just looking at it, I have lots of addition, lots of subtraction, and I have, unfortunately, no sine or no squares. These aren't being squared, so that's going to be a pain in the butt. So I'm adding two fractions. In order to add two fractions, in order to add these fractions, I have the common denominators. So I'm going to take this denominator here and multiply it by its version of 1 to both sides. I might need more paper for this one. So, in order to get this one to have common denominators, 1 over 1 minus sine x plus 1 over 1 plus sine x equals to secant squared x. Okay, in order to get these to be common denominators, I'm going to take this one, use this denominator, 1 plus sine x over 1 minus, or 1 plus sine x. So I'm multiplying this denominator over itself to this one. And I'll do the same thing over here. I take this one, and this will be 1 minus sine x times 1 minus sine x. That makes these common denominators. Really not using this side of it right now, so we'll just leave this. This is just the left-hand side. So what I get there is I'll have 1 plus sine x over 1 plus sine x times 1 minus sine x. And this is going to be 1 plus sine x times 1 minus sine x, the same thing, the common denominators, which means I can bring this one over, 1 minus, oh, this will be a minus, sine x. So I have 1 plus sine x plus 1 minus sine x. Right, those are plus, yep. Now, I have a positive sine x on top and a negative sine x on top. Those are going to zero out, which leaves me with a 2 on top. Now, a plus b times a minus b, that's difference of squares. So this will be 1 squared minus sine squared. 1 squared is 1 minus sine squared x, difference of squares. And then this is just cosine squared. So this will be 2 over cosine squared theta. So, jot some of this down over here. We end up having 1 plus sine x plus 1 minus sine x all over 1 plus sine x times 1 minus sine x. Force them to be common denominators. We want to make sure that equals 2 secant squared x. Now those signs canceled out, leaving me a 2 on top. And we did difference of squares to make that 1 minus sine squared x. One minus sine squared x is cosine squared x, so 2 over cosine squared x equals to secant squared x. And cosine is just, that's on the bottom, so that's the reciprocal. We take the reciprocal and move it to the top, and we get to secant squared x equals to secant squared x. Check mark. We're done. Okay, this next one here. 1 plus cosine of 2 alpha over sine of 2 alpha equals cotangent of alpha. Now I have two different size of angles here, so I need to try and fix that. We are going to use the double angle formulas on this side here. So cosine of 2 theta, there is only, is that the one that has more than one. Cosine, sine, cos, sine. So no, this is the one that has multiple ones. So sorry, cosine, I believe, is the one that has multiple ones. Yeah, because you can square them and then use some other stuff. Okay, so cosine of 2 alpha. We're not going to figure out which one we want to use here in a second. I know sine of 2 alpha. That only has one option that we can really use, and that is going to be, you'll get 2. So sine of 2 alpha is 2 sine alpha cosine alpha. And then cosine of 2 alpha, that is going to be, we have a couple of options we can use. We can use either the double cosine square, we can use the cosine, we use cosine squared alpha plus sine squared alpha, or we can use some of the other ones, which is the stuff like 1 plus 2, let's do that one. Let's try, this would be 1 plus cosine of 2 alpha is, what is that? That's, hold on, I can dig this out of my brain. It's going to be, so sine squared plus cosine, it's going to be cosine squared minus sine squared. It's been a long time since I actually memorized these. Cosine squared alpha minus sine squared alpha. So we do, that's 1 minus, so we can use 2, let's try this one first. 2 cosine alpha minus 1. We'll try that one. I have 3 different options to use. I'm going to try this one because what happens there, I have a negative 1 on it, I have a positive 1 here, so they're going to cancel out. So let's see what happens there. So when that happens, those 0 out, and that gives me 2 cosine alpha 1 minus sine squared. It's not working out. I may have messed up here. Let's find out what happens. That's be cotangent. That's why I was seeing right. So 2 sine alpha cosine alpha. Oh, this should be cosine squared alpha. Cosine squared alpha. Okay. And then, so when that happens, the 2's cancel out. 1 cosine cancels out on bottom, 1 cosine cancels out on top, so that leaves us with cosine alpha over sine alpha, which is just cotangent of alpha, which is the same. Okay, so it worked. It worked. Oh, went off the screen there. So I used one of the double angle formulas. And so I use the 2 cosine squared alpha minus 1. That way the positive 1 and the minus 1 zeroed out. And then that left me 2 cosine squared alpha on top. These two, now that there's no addition or subtraction, I can simplify. So these 2's canceled out. 1 cosine canceled out one of the 2 cosines on top, leaving me cosine over sine, which is cotangent, which is what the other side was. So awesome. That did work out. Here is those are the exact same, right? I'm not insane, am I? 1 plus cosine 2 alpha, sine 2 alpha, cotangent. Okay, well, those are the same. So, double. Okay, that completes it. That was the longest of all the videos. So, good luck, and ask me more questions if you have them.